Good morning. I've had a request for some extra help with lesson 3, a bit of a demo of how to do some of the questions. So they're all about things you can do with 2 points. The distance between 2 points, the middle of the 2 points, the gradient, the slope between the points, and the perpendicular bisector of those points. So that's what we're going to do. I guess that means we need 2 points. So let's have a negative number, minus 2, 6, point number 1, and let's have another point at 3, 5. Okay, so these 2 points are what we're going to find all of these out about. So the distance between the 2 points. Let's think about what happens if I go from minus 2, 6 up to 3, 5. So no pictures today, I'm just going to work with the algebra. The pictures are available in the past video. So x coordinate, y coordinate, x coordinate minus 2 up to an x coordinate of 3. So how far have I gone across the x axis, going across from minus 2x coordinate up to 3x coordinate? I've gone across by 5. So what am I saying? Change in x equals 5. What do I mean by that? I mean that the distance across from minus 2 here all the way up to 5 here on the x-axis, y-axis is somewhere there, how far have I gone across? 1, 2 to 0, 1, 2, 3. Sorry. So that's 1, 2, 3, 4, 5. I've gone across by 5 units to get from minus 2 on the x-axis up to 3 on the x-axis. So this means the change in x is 5. Capital letter delta, Greek letter. Change in x is 5. Well, let's think about the change in y. How much has y changed by? Well, y coordinates have gone from 6 down to 5. So the change in y is minus 1. To get from there to there, my x coordinate goes up by 5. My y coordinate goes down by 1. So what does that mean? It means that I've gone across 5 and then down 1. So that's 5 across and down 1. And that means I can work out the distance, the length of that line that goes between these 2 points here. It's Pythagoras using the lengths 5 and 1. So the distance, how am I going to work it out? I'm going to do 5 squared plus 1 squared, which is 26. And I'm going to then do distance between the points equals the square root of 26. There we go. So the midpoint of the 2 points. Well, this is a very similar idea. On the x-axis, I'm going from minus 2 up to 3. So I have to figure out where the middle of those 2 points is. I've got a little picture here, that's nice. So I can see the middle is probably about there. I think that's at a half. Let's see it by counting and then we'll do some maths to check. So minus 1, 0, 1, 2, 3. So let's count back in. So from each edge, here we go. From each edge, go in 1, go in 2, and then in the middle is 0.5. So the midpoint of the x is going to be 0.5. The middle of the y is easier. Well, because I've got y equals 6 there and y equals 5 there. So halfway between those two is at 5.5. I'm happy with that one. I'm just not completely happy with this one. So here's a way I can use some math to check. The midpoint, the balance point, the average is the average. It's the mean of the 2 numbers. So I could add up my 2x coordinates, which are minus 2 and 3. I could do minus 2 and 3 and add them up, and then half the answer. And I'm finding the mean or the average of those 2 numbers. So minus 2 plus 3 equals 1. Yeah, 1 over 2, a half. Great. There we go. So if you look in the notes that are linked from lesson 3, then it will direct you to a big, long, crazy formula, which you can write down and use to find midpoints if you want. I prefer personally to look at the coordinates and think, right, where's the middle of the x coordinates? Where's the middle of the y coordinates? And if you need to check, you can do a bit of math so you can work out the average of the two x coordinates for the x midpoint. Okay, good. So now we're going to look for the gradient, which was the slope of the line. We've already got a wee picture here. It's kind of going down gradually. Now the gradient is defined by this concept of it's how much you go up or down divided by how much you go across. So specifically, if the change in x is 1, if I go across by 1, then the gradient is just how much I go up or down every time I go across by 1. In this example, we've already worked out the change in x and the change in y. So the change in y is from 6 down to 5 is -1. The change in x is from -2 up to 3. So that's +5. So it's -1/5 is the gradient. And I would just leave it like that. That's not a nice fraction. A little bit of fun with the gradient that is worth just showing to you. If you had these 2 points, I kind of just chose I was going to go this way round. Let's just find the gradient for a bit more practice between these 2 points. What if I start at 3, 5 and then go to -2, 6? Well, then what happens? So pause the video for a second and try and work out the change in the y coordinates and the change in the x coordinates. Okay? So now you've unpaused. Change in the y coordinates is from 5 up to 6, so that is up by 1, +1. Change in the x coordinates is from 3 down to -2, so that's going down by 5. So the gradient is the change in the y divided by the change in the x, which is 1 divided by -5, which is the same thing as just about room here, -1/5. So that's again the same thing, -1/5, same thing as we had here. So it doesn't matter which way round you go, so long as you just, I always write this, you know, with a little arrow just to show myself and remind myself. I'm going from 3 down to -2, that's down -5 on the x. Great. Perpendicular bisector is the best one. They love it on exams, and they love it on exams because it kind of puts all of this stuff together. All of the skills, and more, actually. So, perpendicular, what does that mean? It means crossing at right angles like that. Bisector, what does that mean? It means crossing through the middle. Bi, cut in half, bisect. So, it crosses through the middle. That means it goes through the midpoint, and we worked out the midpoint up here. So the fact that it's a bisector, that means it goes through the midpoint, which was 1/2 and 5.5. I mean, a nicer way is probably to write 1/2 and 11/2. Probably a nicer way of doing it, but anyway. Perpendicular means it goes at right angles. Now we already worked out the gradient between these 2 points was -1/5. So we know that the gradient between the 2 points, which call it m, is going to be -1/5. We need to work out the perpendicular gradient, normally written like that, or sometimes written like this, m perp. That's obviously a little symbol for perpendicular. Maths are like that, nice, quick, little, easy treat ways of writing things. So we know that, to work this out, we know, fact, again in the notes and explained why, that the gradient times by the perpendicular gradient always equals -1, which is a really cool true fact about the universe. Okay, so if this is true, then what we know is that m already is -1/5, so -1/5 times by something equals -1. I reckon this is the number 5, right? -1/5 times by 5 gives me -1, so I can solve that. If you want to, the way to do it is to divide by -1/5 both sides, technically. So perpendicular gradient is -1 divided by -1/5, or I could write it like this, -1 divided by -1/5. And you remember that when you divide by a fraction, you flip it over, okay, and then you multiply. So that's like -1 times 5 over -1. -1 times -5 is +5, divided by 1, nothing much happens there, so 5. But you get good at practice, and there's a really good exercise in, I think it's lesson 1 or 2, where you practice spotting that -1/5 and 5, they are perpendicular gradients to each other. You flip it over and flip the minus sign. Anyway, that was a very long way round, sorry, of saying that we should end up with a perpendicular gradient of 5. So if we know that m perp is 5, and we know that I'm going through this point, let's do it with fractions, it's fun, then that's the bisector, that's the perpendicular. I can just work out and basically write down what the equation of this line must be, this perpendicular bisector. I recommend this form: y minus b equals m perp, remember, lots of x minus a. So we're going to put in the perpendicular bit and we get 5. We're going to put in the coordinates, so the coordinates a, b, so it's x minus a half and it's y minus 11 over 2. And then we can just expand the brackets. Make sure that you can see it this time. Expand the brackets, so y minus 11 over 2 is 5x minus 5 over 2. And I think this question said leave it in the form ax plus by plus c equals 0. So x is positive here. Let's move stuff around. Let's subtract y off both sides and add 11 over 2 on both sides. So I'm going to have 0 equals 5x minus y minus 5 over 2 plus 11 over 2. Minus 5 plus 11 is, I think, 6. So 0 equals 5x minus y plus 6 over 2, which means that 0 equals 5x minus y plus 3. There we go. Equation of a perpendicular bisector by breaking it down, finding the midpoint, finding the gradient, flipping the gradient to find the perpendicular gradient, and putting those two things together using our favourite equation of the line for a point and a gradient. Hope that helps.